of f of x is equal to x square minus x plus 1 by x square plus x plus 1. There is a shortcut formula for finding range of such function. And the formula is like this. If f of x is equal to ax square minus bx plus cy, where b square minus 4ac is less than 0, then minimum and maximum values are given by f of plus or minus under root c by a. So here the given function is of this form, where delta is less than 0. So minimum value is f of c and a both are equal to 1 for us. So root 1. So f of 1. What is f of 1? 1 by 3. Maximum value is given by f of minus root c by a. F of minus 1. Find f of minus 1. We'll get 3. Therefore, what is the range? Closed interval 1 by. Option A is right. So remember this shortcut formula. Next f maps R to R. F of x is x square plus 1. We have to check whether it is 1 over on R2. What is the domain of the given function? Given domain is first set. First set is given as all real values, which means this function is defined for all real values of x. So I can take any value for x. Let us say I am taking f of 2. What is f of 2? 2 by 5. Now tell me f of 1 by 2. 1 by 2 by 1 by 4 plus 1. That is equal to 1 by 2 into 4 by 5, which is 2 by 5. Which means f of 2 and f of 1 by 2 are equal. Therefore, function is not 1 1, because as per the definition, 1 1 means different elements should have different images. But here 2 and 1 by 2 are having same image, and hence it is not 1 1. Then what is onto? How to check whether the function is onto or not? For that, let the given function is y. Denominator will be more than numerator always. Denominator will be more than numerator. Correct? X square plus 1 will be always greater than x. If numerator is greater than denominator, its value will be always a fraction. So y will be, given function is always a fraction. It can be either positive fraction or negative fraction. But what is the codomain given? Second set, all real values. We came to know that y is only a fraction, but codomain is given as all real. So range and codomain are not equal. Range of y is not equal to codomain. Therefore, f is not onto. How can you say that without doing any calculation that range is not equal to codomain? Codomain is given as all real, but y cannot be all real values, because if you look at the given function, denominator will be always more than numerator. If denominator is more than numerator, definitely it will be a fraction. It cannot be more than 1. But codomain has all real values. So codomain and range cannot be seen, and hence the function is not onto. So answer is neither 1 1 nor onto. Option D is the correct answer. Next, f map z to z such that f of x is 6x minus 11. Then f is 1 1 or onto. You need to check. Take any integers, or how to check whether the function is 1 1 or not. let f of x1 is equal to f of x2, and if we can show that x1 is equal to x2, then we can say the function is 1 1. What is f of x1? 6x1 minus 11 is equal to 6x2 minus 11, implies 6x1 is equal to 6x2, or x1 is equal to x2. Therefore function is 1 1. Next, how to check whether it is onto or not. Consider the given function as y. What is x from this? Y plus 11 by 6. Now, f is mapping from z to z. So, x is integers and y is integers. Now, if y is equal to 2, let us say, then x becomes 13 by 6, which is not an integer. So, if y is an integer, you should get x as integer for the function to be onto. Because what is the definition of onto? For every b belongs to b, there should exist a belongs to a such that f of a is equal to b. But for y is equal to 2, you are getting x is equal to 13 by 6, which is not an integer. Therefore, f is not onto. So, it is 1 1 but not onto. Option A. Next, f is mapping from R to R, and f of x is given as 4 power x plus 4 power mod x. Now we have to check whether it is 1 1 function or onto function. Now let us define this function. Mod x can be written as x, and x is positive. If x is 0, 4 power 0 plus 4 power 0, 2. When x is negative, mod x should be written as minus x. So what are the three values for f of x? One is 2 into 4 power x. 2 when x is equal to 0. 4 power x plus 4 power minus x when x is less than 0. Now we have to check whether it is 1 1 or not. Clearly, for different values of x, for different elements, check whether it has different images or not. If you take positive values of x, function is 2 into 4 power x. For 0, you get 2. For negative, 4 power x plus 4 power minus x. So, for different elements, we get different elements have different images. Therefore, f is 1 1. Then when we say that function is onto, if range and codomain are equal, function is onto. What is codomain given? All real values. But here, function is not equal to 0 for any values of x. This function cannot be 0 anywhere. Which means 0 will not be there in the range of f of x. But what is codomain given? All real. So, f of x cannot be 0 for all real values of x, and hence range is not equal to codomain. Because in range, all real values are there, but in codomain all real values are given, but in range 0 will not be there. Because f of x can never be 0 for any value of x. So range and codomain cannot be equal, and hence the function is not onto. Any function which is not onto is said to be into. So answer is 1 1 and into. Option A. Next, number of 1 1 functions that can be defined from A to B is given. Then what is n of B? The formula for number of functions that can be defined from A to B is equal to n of B power n of A. That implies n of B power n of A is 4 is equal to 5040. 5040 is power of which How to write 5 for 5040? Is it 9 power 4? No. 8 power 4. Sorry, it is not functions, right? Number of one functions. Sorry. Number of one functions that can be defined from A to B is n of B, P n of A. Sorry. The question is not functions, one functions. The formula for number of one functions that can be defined from A to B is n of B P n of A, which means n of B P n of A is 4 is equal to 5040 given. How to write 5040? 10 into 504. 504 can be written as 9 into 945, 9 into 40, sorry, 9 into 56, and that 56 can be written as 8 into 7. So what is 10 into 9 into 8 into 7? 10p4. So n of p p4 is equal to 10p4 means n of p is 10. So remember the formula for number of one functions that can be defined from A to B is n of A, n of B, P, n of A. P stands for permutation. So option D is correct. Next, n of A is given as 5. Number of elements in A is 5. What is the condition to define a surjection from A to B? See, for surjection, the basic condition in terms of number of elements is n of A should be greater than or equal to n of B. If surjection is from set A to set B, which means 5 should be greater than or equal to n of B, or n of B should be less than or equal to 5. Option C is correct. So for surjection or onto function, the condition is n of A should be greater than or equal to n of B. N of A is given as 5. So 5 greater than or equal to n of B means n of B less than. Next, what is the number of functions from A to B? Just now here, number of functions that can be defined from A to B formula is n of B power n of A, which is 2 power 3, 8, option B. Number of non-bijective matrix. What is total number of functions? Just now I gave formula. N of B power n of A. Here B is A itself. A to itself means A to A. So n of A power n of A, which is 3 power 3. And the formula for number of bijections, not bijective functions. Number of bijective formula is n of A factorial, which means 3 factorial, 6. So out of total 27 functions, 6 are bijective functions. Therefore, what is number of non-bijectives? (27 minus 6), 21. Option A is correct. If f of x is equal to x by root 1 plus x square, then f of x is equal. There is a formula shortcut for this. If f of x is equal to x by under root 1 plus x square, then the shortcut formula f circle, so on, f of x is equal to x by under root 1 plus nx square if f is repeated n times. So the shortcut formula for this, if f of x is equal to x by under root 1 plus x square, then f circle, f circle, f circle, how many times that f is repeated? N times. Of x is equal to x by root of 1 plus n x. Here here f is repeated how many times? 3 times. So what will be the answer? N is equal to 3. Since f is repeated 3 times, answer will be x by under root 1 plus 3. Option A is correct. So remember that shortcut. Next, f of x is equal to e power x plus e power minus x by 2. You have to find inverse of this. This can be done easily like this. This is the formula for cos hx. So f of x is indirectly cos hx. So what will be f inverse x? Cos h inverse x. And what is the formula for cos h inverse x? Log of x plus root of. Option C is correct. Next, f of n is given as n by 2 when n is even and minus of n minus 1 by 2 if n is odd. Then f inverse minus 100. This can be done by cross checking. Like this. Let f inverse minus 100 is equal to first option 100. Let us see whether first option is correct or not. Let f inverse minus 100 is equal to 100, which means minus 100 is equal to f of 100. 100 is even number, so what will be f of 100? If n is even, what is f of n? N by 2. So 100 is even, so 100 by 2, which means minus 100 is equal to 50, which is absolutely wrong. Which means first option is wrong. Like that, take option B and let us check. Let f inverse minus 100 is equal to 199, which means minus 100 is equal to f of 199. 199 is an odd number. When n is odd, what is f of n given? Minus of n minus 1 by 2. 199 minus 1 by 2, which means 100 is equal to 198 by 2, which is absolutely false. So option B is wrong. Next, let us check with option C. Let f inverse minus 100 is equal to 201, which means minus 100 is equal to f of 201. 201 is odd number. When n is odd, f of x is minus of n minus 1 by 2. 201 minus 1 minus 1 by 2, which means minus 100 is equal to minus 100, which is correct. And hence option C is correct. So like this, you can cross check with the options given. Third option, C option is correct. Now f of x is given as sine inverse of 3 minus x minus x whole power 4 whole power 3. You have to find f inverse x. The procedure for finding f inverse x for any function is like this. Let f inverse x is equal to y. F inverse minus x, sorry, f inverse x. Let f inverse x is equal to y implies x will be f of y. What will be f of y? Sine inverse 3 minus y minus 6 whole power 4 whole power 1 by 3. The question is finding f inverse x means you have to find the value of y. So from this you have to find y. For that, what will be x cube? Sorry, what will be sin x? If x is sin inverse of that, sin inverse of 3 minus x minus 6 whole power 4. What will be sin x? 3 minus cube on both sides. So what will be sine cube x? That whole power 1 by 3 gets cancelled. So 3 minus. From this, what is y minus 6 whole power 4? 3 minus sine cube x. So what is y minus 6? 3 minus sine cube x whole power 1 by 4. So what is y? Y is nothing but f inverse x. So 6 plus 3 minus sine cube x whole power 1 by 4. Power 1 by 4 means 4th root. Option B is correct. Next, f of x is given, you have to find f inverse 13. As I said, the procedure for finding f inverse is take it as y. So 13 will be f of y. What is f of y? As per the function given, y square plus 4. From this, y square is equal to 9. Y don't say plus or minus 3, only you should take positive values, because for f it is given as 0 to infinity. So y is nothing but f inverse 13, which is 3. Option A is correct. Now f of x is x minus step x, and you have to find f inverse x. As I already told you, for a function to have inverse, it should be a bijection first. Now let us check whether x minus step x is a bijection or not. It is not at all a bijection, because if you find f of 1 you will get 0, if you find f of 2 also you will get 0. Different elements are having same image, so it is not 1 1, and hence not a bijection. If it is not a bijection, inverse doesn't exist, or inverse is not defined. So given function is not a bijection, and hence inverse is not defined or doesn't exist. Option C is correct. So let us start solving problems on functions. F of x is given as 2x plus mod x. Then you have to find f of 3x minus f of minus x minus 4x. How to get f of 3x? Replace x with 3x. 2 into 3x plus mod of 3x. How to get f of minus x? Replace x with minus x. 2 into minus x plus mod of minus x minus 4x. So this is 6x. 3 times mod x minus of minus 2x plus 2x minus mod of minus x is mod x only. Inside modulus you can go negative sign. So what you get here finally? 6x plus 2x, 8x minus 4x, 4x. 3 mod x minus mod x, 2 mod x. Take 2 common, then 2x plus mod x. That is equal to 2 times f of x. 2x plus mod x is nothing but f of x. Option D is the correct answer. So to find f of 3x, replace x with 3x. To find f of minus x, replace x with minus x. Mod of minus x is mod x only, because inside modulus negative sign can be 1. And then substitute the values. After simplification, you will see that it is 2 times f of x. Next, f of 1 is given as 1. And for all n greater than or equal to 1, f of n plus 1 is given as 2 times f of n plus 1. And you have to find f of n. Now put n is equal to 1, because this is a relation is true for all greater than or equal to 1. So I am putting n is equal to 1. Then you will get f of 2 is equal to 2 times f of 1 plus 1. F of 1 is already given as 1, so this becomes 3. 3 can be written as 2 square minus 1. Next, put n is equal to 2. Therefore, f of 3 is equal to 2 times f of 2 plus 1. That is equal to 2 into f of 2 is 3 plus 1, which is 7. 7 can be written as 2 power 3 minus 1. Similarly, if you find f of 4, you will get 15, which is 2 power 4 minus 1. By observing all those values, what will be f of n? 2 power n minus 1. Option C is correct. Put n is equal to 1, you will get f of 2 as 3. 3 can be written as 2 square minus 1. Put n is equal to 2, you will get f of 3 as 7, which is 2 cube minus 1. Similarly, f of 4 you will get 15, which is 2 power 4 minus 1. F of n will be 2 power n minus 1. Option C is the correct answer. Next, f of x is given as cos square x plus sin power 4x by sin square x plus cos power 4x, and the question is finding f of 2016. Now let us simplify this. I am writing sin power 4 as sin square into sin square by cos power 4 as cos square into cos square, and that is equal to cos square x plus sin square x into, in place of the other sin square I am writing 1 minus cos square x by, similarly in denominator sin square x plus cos square x into, in place of other cos square write 1 minus sin square. Now if you simplify this, cos square x plus sin square x into 1 minus sin square x into cos square x by sin square x plus cos square x into 1 minus sin square x cos square x. What is cos square theta plus sin square theta? 1 minus, in denominator also you will get 1 minus, so both gets cancelled. F of x is equal to 1. If f of x is 1, what is f of 2016? X should be replaced with 2016, but we don't have any x term, again you get 1. Not only f of 2016, even if question is f of 2024, answer is 1 only. Because f of x we got it as constant. So f of anything will be the same constant. So option A is correct. Next, f of x is given, and we have to check whether the function is even function or odd function. To check whether the function is even or odd, as we already discussed in synopsis, we have to find f of minus x. Replace x with minus x. That is equal to minus x by e power minus x is 1 by e power x minus x by 2. After taking LCM, that e power x will go to the numerator by 1 minus e power x. This can also be written as x e power x. So f of minus x is equal to x into that minus e power x I am writing like this. Add and subtract 1 by this is minus x e power x. I took x out, and minus, for a minus e power x I added and subtracted 1. Now split this into two terms. X into 1 minus e power x by 1 minus e power x is x minus x by 2 plus 1. What is x minus x by 2? Plus x by 2. Minus x by 1 e minus e power x can be written as plus x by e power x minus 1 plus 1. So what is this? This is nothing but given function f of x. This is nothing but given function f of x. So I got f of minus x as f of x. What does it mean as per the definition? It is an even function. Option B is correct. Okay. Next. What is the period of cos of x square? So what is the definition of periodic function? If f of x plus t is equal to f of x, then the function is said to be periodic and the least value of t is said to be the period. Now for f of x is equal to cos of x square, for no value of t you will get f of x plus t as f of x. So this is not a periodic function. This is not periodic because for no value of t, f of x plus t will be f of x. And hence the function is not periodic or period doesn't exist. Option D. Periodic function means by replacing x with x plus t should be the same function. But here for cos of x square it is not possible for any value of t where f of x plus t becomes f of x. And hence it is not periodic or period doesn't exist. Now f of x is equal to e power cos of that. What is the meaning of the bracket given? Sorry, this bracket, this function should be like this. Look here. Cos of fractional part of x plus sin pi. Okay. This is e power. Fractional part of x is nothing but x minus step x. Step x is always an integer. Any integer into pi, n pi is 0. Sin n pi is 0. So this is nothing but e power cos of x minus step x. Now, period of x minus step x is 1. Because if you find f of x plus 1, replace x with x plus 1. So this is x plus 1 minus step of x plus 1 can be written as step x plus 1. Step of x plus k can be written as step x plus k when k is an integer. Here 1 is an integer. So here 1 gets cancelled and what is left out? So I got f of x plus 1 is equal to f of x. So what is the period? Period is 1. So wherever you have the function x minus step x, its period will be 1. So period of this function is also 1. Option A is correct. Remember, step of x plus k can be written as step x plus k, not always, only when k is an integer. So wherever the function contains x minus step x, remember its period is 1. Next, domain of the function. What is the definition of domain? It is a set of values of x where the function is defined. Given function is defined when denominator is not equal to 0. So given function will be defined when this is not equal to 0, and if you write factors for this, you will get x plus 2 into x minus 3. It should not be 0, which means x should not be minus 2 or x should not be 3. Therefore, what is domain? X can have any real values except these two. So domain is all real minus set of minus 2 comma 3. Option A is correct. Sorry. Option. So given function is defined when denominator is not equal to 0. So x should not be -2 and x should not be 3. So x can have any real numbers except those two. Except those two means flower bracket or set. So R minus set of -2, 3 is the domain of the given function. Next, the domain of 1 by log mod x. Domain means set of values where the function is not defined, where the function is defined. Here the function to be defined, log mod x should not be 0, which means mod x should not be 1, which means x should not be plus or minus 1, and the logarithm is not defined when x is equal to 0, so x should not be 0 also. X should not be 0 because log 0 is undefined. Mod x should not be 1 because if mod x is 1, log 1 is 0, 1 by 0 is undefined. So x should not have these three values. So what is domain then? All real values except these three. Option C is correct. Logarithm is not defined for 0, so x should not be 0. And denominator should not be 0. Which means log mod x not equal to 0, mod x not equal to 1, x should not be plus or minus 1. So x should not have three values. So domain is all real except those three. Next, again domain of the function. Here denominator should not be 0. Three power x is not equal to 3 power minus x. This is 1 by 3 power x. Do cross multiplication. 3 power 2x not equal to 1. 1 can be written as 3 power 0. So 2x should not be 0 or x should not be 0. If x should not be 0, what is the domain then? All real except 0, which is same as all real means minus infinity to infinity minus 0, which is also written like this. All the three gives the same meaning. All are one and the same. So here option B is the correct answer. Next, domain of 1 by under root mod x minus x. The given function is defined when the function inside the root, that is mod x minus x, should be positive. The function inside the root should be positive here, which means mod x greater than x. Mod x greater than x is satisfied for what values of x? The above condition is, so the above condition is satisfied for all negative real values of x. How can we say that above condition is satisfied for all negative real values of x? Take some example. Let us say x is minus 2.6. What is mod of minus 2.6? 2.6 greater than minus 2.6, which is true. So this condition mod x greater than x is satisfied for which type of values of x? Only for all negative real values. If you take positive number, it is not true. For example, let us say 3.85. Mod 3.85 greater than 3.85. Mod 3.85 is 3.85. So 3.85 greater than 3.85 is not correct. So this condition is satisfied for all negative real values of x. So what will be the domain? All negative means from minus infinity to 0, open brackets, because 0 also doesn't satisfy the given condition. So option A is correct. Next, here we have sum of two functions under root x minus 2 plus 1 by log of 4 minus x. So whenever we require domain of sum of two functions, we have to find the individual domains and then intersection of those two. First, let us find individual domains. The function inside the root should be greater than or equal to 0. So x greater than or equal to 2 is the domain condition for the first function. Next, here log of 4 minus x should not be 0 because it is in denominator, and 4 minus x should be positive, and 4 minus x should not be 1. No, sorry. Log of 4 minus x should not be 0 because it is in denominator, and we know that logarithm is defined only for positive numbers, so 4 minus x should be positive. Log of 4 minus x not equal to 0 means 4 minus x not equal to 1, which means x not equal to 3. Here 4 minus x greater than 0 means x less than 4. So we have three conditions. It should be greater than or equal to 2, it should be less than 4, and x should not be 3. Then what will be the domain? Greater than 2, less than 4 means it lies between 2 and 4, including 2, excluding 4, minus 3, because 3 should be excluded. So closed bracket 2 comma 4 open bracket minus 3, which means 2 to 4 except 3. Option C is correct. Because in option C, open bracket is given for 3. It means that 3 is excluded. So the domain which I wrote here and option C both gives the same meaning. So remember, whenever the question is finding domain of sum of two functions, find individual domains and then intersection of those two. Greater than or equal to 2, less than 4 means it lies between 2 and 4. But 3 should be excluded. I will proceed to the next one. The domain and range of f of x is equal to 4 minus x by x minus 4. What is the domain for this? Denominator should not be 0. It is a basic condition, which means x should not be 4. Implies what is domain? All real values except 4. Next, given function 4 minus x can be written as minus of x minus 4. This can be written as minus 1 because already we wrote the condition x is not equal to 4. So how f of x will be always? F of x is always minus 1. So how many values f of x possess? Only one value, which is minus 1. Therefore, what is the range of f of x? Only one value in singleton set. Set of minus 1. So domain is R minus 4, R minus set of 4. Range is only set of minus 1. Option C is correct. Next, range of f of x is equal to 1 by 1 minus 2 points. You should listen this carefully. What is the range of 1 minus 2 points? We know that cos x lies between minus 1 and 1. Multiply with 2. If you multiply with minus sign, inequality gets changed. Add 1. Which means minus 1 less than or equal to 1 minus 2 cos x less than or equal to 3. Now if you take directly reciprocal and if you write 1 by minus 1 to 1 by 3, option B, which is wrong. Listen here. Here 1 minus 2 cos x lies between minus 1 and 3. In that minus 1 and 3 we have negative values as well as positive values. So first you have to split this like this. When 1 minus 2 cos x lies between minus 1 and 0, its reciprocal, because we require 1 by 1 minus 2 cos x. Its reciprocal lies between, see, between minus 1 and 0 means all negative values. Between minus 1 and 0 means all negative values will be there. So when you take reciprocal of 0 is infinity, reciprocal of minus 1 is minus 1. So 1 by 1 minus 2 cos x lies between 1 by 1 minus 2 cos x lies between infinity and minus 1. So remember, first between minus 1 to 3 you have to split negative values and positive values. So minus 1 to 0, and we require range of 1 by 1 minus 2 cos x. 1 minus 2 cos x lies between minus 1 and 0 means all negative values will be there. If a function is negative, then its reciprocal is also negative. Here it lies between minus 1 and 0, so reciprocal lies between minus infinity and minus 1. Next, take 0 to 3. If 1 minus 2 cos x lies between 0 and 3, you have to split minus 1 to 3 as minus 1 to 0 and then 0 to 3. Then its reciprocal lies between 1 by 0 infinity. 0 to 3 means positive values only. So reciprocal is also positive, and reciprocal lies between 1 by 3 and infinity. So 1 by 3 less than or equal to 1 by 1 minus 2 cos x is less than. So the given function lies between minus infinity to minus 1 union 1 by 3 to infinity. Option C is correct. Here it lies between minus infinity to minus 1. Here it lies between 1 by 3 to infinity. So what is the range of the given function? Means union of these two. Option C is the correct answer. Next, the domain and range of the function. Domain. The given function is defined for all real values of x. Because given function is defined for all real values of x. Therefore, what is domain? Capital R. Then how to find range? How 2 minus mod of x minus 5? See, mod of x minus 5 is always positive, or it may be 0. When x is 5, it will be 0, otherwise it is positive. 2 minus a positive number will be always less than or equal to 2. 2 minus, see, mod of x minus 5 is always positive, or it may be 0. If it is 0, this will be 2. Otherwise, it will be less than 2 because we are subtracting a positive number from 2. If we subtract a positive number from 2, the overall value will be less than 2 only. So this is always less than or equal to 2 implies less than or equal to 2 means minus infinity to 2. 2 is included, and for in minus infinity always you should put open. So range is minus infinity comma 2 and domain is all real values. Option B is correct. Next, f is equal to set of x such that x comma x square by x square plus 1 such that x belongs to R. Be a function R into R, then what is the range of f? What is the function given? X square by x square plus 1. But find range of this function. Clearly, denominator x square plus 1 is always greater than x square. X square plus 1 is greater than x square, which means numerator is greater than denominator. If numerator is greater than denominator, how the range will be? If numerator is greater than denominator, its value will be less than 1, and it is always positive. X square by x square plus 1 is always positive. And since denominator is more than numerator, it will be a fraction. So what is a positive fraction? 0 to 1. This function can be 0 when x is 0. So 0 is included. And this function cannot be 1. So 1 is excluded. So range is set of 0, 1. Option A. Or you can explain in a different way like this. Add and subtract 1 in numerator. Split this into two terms, 1 minus 1 by x square plus. 1 by x square plus 1 is always positive, and we are subtracting a positive number from 1, which is always less than 1. This is always less than 1. And f of x is greater than or equal to 0 always. Because x square by x square plus 1 is always positive. It may be 0 or positive. And less than 1. More than 0, less than 1 means lies between 0 and 1. 0 is included, 1 is excluded. So 0, 1 with left open. Sorry, left closed, right open. Option A is correct. So I explained this in two different ways.